Welcome to The Explainer. Today, we're jumping straight into a truly thrilling, high-stakes medical frontier. We're going to explore how artificial intelligence is solving a literal life-or-death bottleneck that's happening right now in emergency rooms all over the world. We're looking at medical MRI AI scanners. And, not as some distant, futuristic sci-fi concept, but as a hyper-fast, collaborative assistant that's actively changing how we treat medical emergencies today.
To really grasp why this technology is such a game changer, you first have to understand the terrifying biological stakes. 1,900,000, that's the exact number of brain cells that die every single minute a patient is suffering from a stroke. Every tick of the clock is measurable, permanent damage. Speed isn't just a nice-to-have advantage here, speed is literally survival.
Okay, let's dive into this. What happens when the diagnosis takes 40 minutes? Well, here is where the system really starts to break down. A patient rushes into the ER, they get an MRI, but then the whole process just halts. Traditional MRI interpretation takes anywhere from 20 to 45 minutes. Why? Because a human specialist needs to painstakingly review between 150 to 300 individual images. And during that 40-minute wait, millions upon millions of brain cells are actively dying.
Section 1. The stroke time crisis. Every minute matters.
So in emergency stroke care, time is the absolute core of the universe. And that leads to what doctors call the golden hour paradox. Imagine this, you're an ER doc. You've got the clot-busting medication drawn up in a syringe, literally ready to save your patient's life, but you cannot legally or safely administer it until a radiologist confirms the MRI. It's exactly like standing inside your burning house with a fire extinguisher in your hands, but being told you have to wait 30 minutes for official permission to pull the pin. It's a paralyzing delay.
Let's move to and see how this builds into Section 2, the radiologist bottleneck, the hidden crisis.
You see, this delay isn't the fault of slow doctors. It's actually the result of a hidden systemic crisis, the severe shortage and extreme cognitive burnout of radiologists. A 2023 study in the Radiology Journal found that a radiologist's baseline error rate stays fairly steady for the first 8 hours of their shift. But right after hour 8, there's a sharp 12% spike in errors for every single hour they work after that. It's just pure cognitive overload. Asking a human brain to flawlessly analyze thousands of black and white medical images back-to-back is inevitably going to lead to fatigue. To put a human face to that data, listen to Dr. Lisa Thompson from the American College of Radiology. She says, "The most stressful part of emergency radiology is the fear of missing something critical when you're exhausted." I mean, just imagine being on hour 10 of a shift at 2 a.m., knowing that if your tired eyes miss a subtle 3mm hemorrhage on slice number 142, someone might die. The pressure there is just immense.
Section 3. Enter AI medical scanners, stopping the clock. And this brilliantly illustrates exactly where the technology steps in. Now, it's super important we frame this correctly. This is not a robot replacing a doctor. This is a hyper-fast, highly advanced collaborative assistant designed to do one main thing: stop the clock. In a massive 12-hospital international trial reported by Reuters, the traditional workflow left patients waiting an average of 38 minutes for a diagnosis. But by implementing an AI-assisted workflow, that average wait plummeted to just 23 minutes. The AI shaved a full 15 minutes off the diagnosis time by instantly flagging abnormalities for the doctor to review. So why does 15 minutes matter so much? Well, based on the biology we talked about earlier, shaving off that wait time preserves 28.5 million brain cells per patient. That's literally the tangible difference between a patient walking out of the hospital under their own power a week later versus needing a wheelchair for the rest of their life.
Now, what's really interesting about this slide is that speed doesn't come at the cost of accuracy. A BBC-reported study matching AI against 12 board-certified human neuroradiologists showed the AI actually slightly edging out the human average. It hit 96.2% in sensitivity and 97.1% in specificity. But honestly, the real game changer here is performance variation. Human variation was almost 9%, heavily dependent on how tired the doctors were. The AI's variation, just 2%. It offers incredible consistency. It never needs a 3 a.m. coffee break, and its eyes never get heavy.
Section 4. Rapid diagnosis in action, the new workflow.
So how does this actually work in practice? It's a really seamless sequence. Step 1, the MRI is acquired just like normal. Step 2, here's the magic. The images are automatically sent to the AI, which performs a deep learning analysis in just 90 seconds. Step 3, the AI instantly pings a prioritized alert to the on-call radiologist, flagging the exact location of the potential stroke. And Step 4, rapid confirmation. The human doctor reviews the preliminary findings and makes the final call. The AI does the heavy lifting, for sure, but the human physician firmly remains the ultimate decision-maker.
Dr. Sarah Chen, over at Massachusetts General Hospital, perfectly summarizes this dynamic. She notes, AI doesn't replace my expertise, but it gives me a head start, rather than spending 20 minutes searching through 300 images. Think of the AI as the ultimate sidekick. It hands the doctor a fully highlighted roadmap, which lets the physician apply their years of clinical judgment right away, instead of wasting precious time just hunting for the starting point.
Section 5. Beyond speed, accuracy and equity, the macro impact. When we zoom out from the individual patient, we start to see how this 15-minute speed advantage ripples out into massive system-wide impacts across the entire healthcare landscape. Let's talk economics for a second. A Johns Hopkins Health Affairs analysis proved that hospitals save an average of $18,400 over the lifetime of each stroke patient treated using this workflow. Why? Because a faster diagnosis means faster treatment, which dramatically reduces those devastating long-term complications that require years of expensive rehab. The technology literally pays for itself by keeping people healthier.
And perhaps even more importantly, it's democratizing healthcare. According to an AP News report, this AI has been deployed in 45 rural hospitals, places that typically don't have brain specialists on staff. By using this AI, these small-town hospitals saw a staggering 90-minute reduction in wait times for specialist interpretations. It led to a 60% decrease in forcing patients into expensive helicopter transfers to big city hospitals, saving each rural facility about $1.8 million a year. It's basically bringing world-class medical expertise directly to small-town emergency rooms. So the crucial point is that this technology also heals the healers. Hospitals using traditional workflows report a severe 42% radiologist burnout rate. But in hospitals equipped with this AI safety net, burnout drops all the way down to 31%. By giving doctors a highly accurate, tireless technological partner, hospitals are actively relieving the crushing, anxiety-inducing pressure on their medical staff.
But the ultimate metric, the only one that truly matters at the end of the day, is patient outcomes. A major study published in JAMA Neurology out of Mass General found that this AI workflow translates to a 23% reduction in major adverse events at 90 days. That means 23% fewer patients suffering from permanent paralysis, speech loss, or death. It is an absolute stunning victory for modern medicine.
Which leaves us with this final, vital question to ponder. As this tech becomes more refined and proven across the globe, we have to look at the undeniable moral and economic imperative here. When every single minute costs a patient nearly 2 million brain cells, can hospitals afford not to use AI? Thank you so much for joining me on this explainer. Keep questioning, keep learning, and I'll catch you next time.